In this video, you're going to talk about exponential equations. Equations which involve exponential, and then we have to solve for the variable. Now, an exponential equation, it's an equation where the variable, in this case x, is in the exponent. Or here, x is in the exponent. Or here, x is in the exponent. In this case, we have x on the right and on the left. These are examples of exponential equation that hopefully by the end of the lesson we will be able to solve them. Now, these exponential equations are going to be solved using the facts that we covered in previous lesson. If you remember, we said that if two powers have the same base, then the exponents, they have to be equal, or if they have the same exponent, the bases have to be equal. Meaning, if I have a exponent x is equal to b exponent then it means that since the exponents are the same, this means that a has to be b, equal to b. Or if I have the bases the same, let's say x exponent a equal x exponent b, then it means that a has to be equal to b. So the same exponent, this means the bases, they have to be the same. The same base, this means the exponents, they have to be the same. We are going to use these two facts to solve equations which involve exponents. Now, to put it in words, we are going to use the same property that we said before, that if two powers like these two are equal and the bases are equal, then the exponents, they have to be equal. The condition on the bases is that the bases, they can't be 1 and they have to be greater than 0. Now we are going to go ahead and solve some of these equations. The first example is 5 exponent x is equal to 5 exponent 6. Since the bases are the same, equal to 5, this means that the exponents, they have to be equal. So x is equal to 6. Very simple. Now the next example, 2 exponent x is equal to 32. It is not apparent just by looking that either the bases or the exponents are equal. So what we have to do is to try to express 32 as a power with base equal to 2. It turns out that 32 can be written as 2 exponent 5, because 2 times 2 times 2 times 2 times 2 is going to give you 32. Since the bases are the same, this means the exponents are equal, so x has to be equal to 5. The next example, it's a little bit different, because now we have a linear equation as the exponent. 7 exponent 3x minus 4 is equal to 49. Again, to use any one of those two facts, we have to be able to express the right hand side as a base 7. And this one is obviously equal to 7 exponent 2. So this means, since the bases are the same, 3x minus 4 is equal to 2. To solve this linear equation, I'm going to move negative 4 to the right. I get 3x is equal to 4 plus 2. Negative 4 becomes positive 4 is equal to 6. Divide both sides by 3. I get x is equal to 2. The next example, 3 exponent 5x plus 8 is equal to 27x. Both on the left and right, we have exponent in terms of the variable, but the bases are different. to somehow use the facts 1 or 2, we have to have either the same base or the same exponent. Let's try to express 27 as the base 3. It turns out that 27 can be written as 3 exponent 3. Then exponent 3x. Now using the fact power to power, we multiply 3 by x, we get 3 exponent 3x is equal to 3 exponent 5x plus 8. Since the bases are the same, the exponents, they have to be the same. So 5x plus 8 is equal to 3x. To solve this linear equation, I'm going to move 3x to the left and 8 to the right. So I get 5x minus 3x is equal to minus 8. 5x minus 3x is 2x is equal to minus 8. I divide by 2 and I get x is equal to negative 4. Now the next example, 2 exponent 2 times x minus 5 is equal to 4 exponent 3x minus 1. Again, we do the same thing. We try to express 4 on the right hand side as a power with base 2. So I can write this one as 2 exponent 2 times x minus 5 is equal to 4 can be written as 2 exponent 2 exponent 3x minus 1. Now this is power of power, so I can just multiply these two exponents. So I get 2 times 3x minus 1 is equal to, now to expand 2 in the bracket, I use the arrow method. 2 times 3x gives me 6x minus 2 times negative 1 gives me 9 minus 2. Now the bases are the same, so the exponents, they have to be the same. So 2 times x minus 5 is equal to, I'm going to expand 2 times x minus 5 as 2x minus 10 is equal to this exponent, which is 6x minus 2. This time, since 6x is positive, I'm going to move 2x to the right and negative 2 to the left. So I get 6x minus 2x, because 2x becomes negative, is equal to minus 10 plus 2. 6x minus 2x is 4x, and minus 10 plus 2 is minus 8. Now I divide by 4, and 4 cross out, so I get x is equal to negative 2. So the solution is when x is equal to negative 2. Now one thing you have to remember is that all these examples that we did, the value for x was straightforward and we solved it very easily. But majority of time, this is not the case, and we cannot solve the equations as we did before. This is where we have to use technology. And what I'm going to do is that I'm going to show you how to use a site, something like Desmos, that you can plot the equation and then you can detect the point of intersection. In this example, we have to solve 3 exponent x is equal to 7. It is obvious, as you try it yourself, there is no power with base 3 that is equal to 7. So we have to use either technology or another method which is called divide and conquer. The method is very simple. First we find the two lower and upper bound for value of x. If you look at this equation, you can see that if x is 1, 3 exponent 1 is going to be 3, and 3 exponent 2 is going to be 9, and 7 is between 3 and 9. This means that x is a number between 1 and 2. So this is the first observation, that x has to be less than 2 and greater than 1. The divide and conquer is very simple. It's going to divide the interval in half and then try to see if the value of x that we find is close enough to 7. So, first of all, what is the middle value between 1 and 2? The middle value between 1 and 2 is 1 plus 2 is 3 divided by 2 is 1.5. Now I'm going to try 3 exponent 1.5. If you do that with your calculator, you get 5.2. You can see that 5.2 is less than 7. So this means your x value has to be greater than 1.7. So this means if this is 1 and 2, I tried 1.5. Now I found out that the value really for x is between 1.5 and 2 here. So I'm going to add 2 and 1.5 and then divide it by 2. 2 plus 1.5 is 3.5 divided by 2 is 1.75. So now I'm going to try 1.75. If you use your calculator and evaluate this one, you get 6.84, which, as you can see, we are getting close to 7, but still we are not in the vicinity of 7 yet. So if you look at the number, it's 6.84, which is less than 7. So this means that the new guess has to be between 1.75 and 2. So again, I'm going to add 2 and 1.75, then divided by 2, you get 1.86. So I'm going to plug in 1.86 here in the equation. If you do that, you get 7.72. Oh, you can see that now the value is greater than 7. So your x value is less than 1.86. Remember the value, the lower one before was 1.75. Now we have to find the middle one between 1.75 and 1.86. Again, I'm going to add 1.75 and 1.86 and then divide it by 2. I get 1.81. If I plug in 1.81 in this equation again, I will get 3 exponent 1.81 is 7.3. Getting closer, but still is greater than 7. So now I'm going to say the real x is somewhere between 1.75 and 1.81. Again, I add and then divide it by 2. I get 1.78. So now I'm going to try 1.78. If you plug it back in, you get 7.06, much closer now. But still, 1.78 produces 7.06, which is greater than 7. So I'm going to divide 1.75 plus 1.78 divided by 2, and this time I'm going to get 1.77. And if you plug it back in, you get 6.99. And I think that's enough. It's close enough to 7. So you can say that to 2 decimal points, x is equal to 1.77. This is called divide and conquer method. The next example is to solve equation 2 exponent x is equal to 9 to 2 decimal places. Either you could, first of all, the first thing you have to do is to see if you can express 9 as a power with base 2, which as you know, it's impossible. The second thing you can do is use the divide and conquer method that we talked about in the previous example, or you can use technology. Now, in this example, I'm using the site desmos.com, which I recommend you if you need to use, as a graphing calculator and plotting. This is probably the best site available. What you do is that you are going to plot two equations. One, you express the left one as y equal 2 exponent x, and the right one as y equal 9. Now, if you look at here, I have y equal 2 exponent x, which is this graph here, which I have, and y equal to 9, which is a linear equation, which is this. Now, if you look here, the point of intersection is the value of x that we are looking for. And you can see that the y coordinate is 9, which is y equal to 9, but the x coordinate is the one that we are looking for. And you can see that the x coordinate is 3.17. And if you plug in 3.17 and find two exponent 3.17, you will get 9.00046 and some digits after that, which is close enough to 9. So this is the second method. So the first method that we learned was trying to express everything with the same base. The second method was divide and conquer, and the third method was using technology.